And National Instruments. Okay. So I am Brian Hoover, test software architect at Samsung SDIA out of area near Detroit, where we do automotive stuff for Samsung. I'm a certified LabVIEW architect. I'm a LabVIEW champion. Been doing LabVIEW for a long time. And this presentation is intended to go over package management and reuse. I don't want to focus on one particular package manager more than another, but I definitely will talk about VIPM more than the others. NI, when they approved this presentation, said, we have a lot of presentations on packages this year, and we'd appreciate it if you kind of focused on that. So the first few slides are going to be very high level, doesn't matter what package manager you're going to use. We're going to see a couple of demos with VIPM, and then I'm going to talk about some of the other package managers, but just very briefly, because this is supposed to be more about high level and JKI stuff. I guess before we get going too far into this, I hate audience participation, but I'm going to ask for some. I want to know how many people have used VIPM for package management? Okay. How about NIPM? For package management. Okay, who has made an NIPM package? All right, that's a better question to ask, sorry. All right, and GPM? Yay! All right. So a brief history of reuse, at least for me. I started working at VI Engineering in 2004, and one of my first tasks was to revamp their reuse library. And in doing so, I learned a lot of the things to not do. And that's not necessarily VI's fault. It's just that LabVIEW, we lag behind a bit sometimes when it comes to software development and processes. You know, source code control was a thing that we didn't really adopt nearly as early on. Virtual machines, same way. And so back then, they basically just had a zip. They zipped up their user library, they sent it to all the developers, they unzipped it, and they all had this one monolithic, large reuse library, which was super helpful. There was a lot of good nuggets of reuse in there, and we got a lot of benefit. But there's other problems that came along with it. You know, some of the developers would make things, and then they would leave the company, and no one would support it. They didn't know, you know, bug fixes that were in that thing, or what that thing was even supposed to do. And then there were problems with if you made changes to your user library, and you would name it, you know, Brian's user library version 1. And then you would make changes somewhere else, and I would make changes somewhere else. And trying to get a cohesive single platform that we're all working on and we all knew what each other had was a nightmare. But again, I want to highlight the fact that this was useful. Even though this reuse code caused problems, it was beneficial. So even just sharing nuggets of reuse can save time. There are some that are a little more strict, and they'll say things like, you know, that this ad hoc form of reuse isn't a real form of reuse, and that it'll cause more problems than it solves. But it's definitely beneficial. You know, I remember being in CS 101, and every lesson started with, you have to read from a text file and do something with it. So I reused the read from the text file stuff because that was used in every class. So it was like, that was my ad hoc form of reuse. And I shared that with other students in the class just to get started on the project. So while I was at VI, one of the things that I had to do was revamp the reuse library, as I mentioned. And I had to mass compile it to a new version, and with no documentation and whose version do I use and all this came the senior thesis that I ended up writing my book on to graduate, which was, you know, how do we do reuse at a company? How do we organize it? How do we structure it so that we can benefit the most? Not just this ad hoc sharing onesie twosie VIs, which is nice, but how do we avoid some of the traps of versioning and distribution and that kind of thing? And so several options were looked at the time. This was in the 2008 or 9 era. So VIPM did exist, but I think it was version 1 or maybe 2, and there wasn't much adoption. So we initially looked at doing it ourselves. We'll make our own installers and we'll make our own everything. But in the end, we said that using VIPM solution was probably the best, and I'm glad that it's still around now today, so that some of this content is still useful. Okay, so we're going to talk about some high-level considerations first for LabVIEW, for reuse. I mean, this doesn't even have to be LabVIEW. This is just reuse in general. What should I do? I'm at my company. I want to start reusing my code. Come up with a process. You know, some of us hate the process. Some of us just want to write code. That's it. I understand, but by getting a process up front, you're going to save yourself time. And that process might be as simple as a checklist of saying, here's the things to do. And so I've been at companies where we had a code review that was basically just the checklist of things we cared about. You know, are there overlapping controls? You know, is there comments on the block diagram? And a lot of those things can be checked now with VI Analyzer, which is an awesome, great tool that you should standardize on using at your company. But if you don't, a quick check sheet is fine. You know, the automated process of VI Analyzer is definitely going to save you. But there's a few things that are kind of preferential made that VI Analyzer might not be able to do. You know, are you using the right company logo, or is it scaled or resized properly, and various just simple checks like that. But even having a code review is a great way to train other employees in your company. You know, let them write code however they want, sit them down and say, okay, this is fine code, here's how I would improve it, and here's why. Justify it. Don't just say, you know, never use global variables, they're bad. All right, well, tell me why. Tell me what led you to that, or tell me when they could be used safely. It's a great learning experience, but not the subject of this presentation. So get a code list, or sorry, get a checklist, get a VI Analyzer test, get some kind of standard review process for polishing up your stuff. And you should, because this code might be used for years and years, and you want to make sure that it's the best of the best for you at least, because it will likely be used more than coding once for a project that is for this dedicated thing. You're not going to use that code again unless you go in and data mine and pull stuff out. So you want to make sure that you polish it, make it good. Yeah. Oh, so the other thing is, like, the mindset of reuse is kind of a hard thing to get. You know, when you're developing code, you need to think about how others are going to use it that aren't you. And that's a really hard perspective to put yourself into. To kind of say, you know, what's the default inputs for this? What's the most common uses for this function? Is there internal things that I should expose because somebody else might use it in a way that I don't intend? And that's, again, really hard thing to think about. And even when you're writing code that you don't intend on being reused, it's good to think about that. You know, I'm writing this one VI that's dedicated for doing this one task, but could it be reused in some other way? You don't want to polish a turd forever, but you also want to recognize useful nuggets of stuff that could be reused. And that partially just comes from experience on knowing, will this really be reused, or is this actually very specific and not going to be? And that's just going to come with time, more or less, seeing when it is used and when it isn't. All right. And just like source code control, a lot of people are opposed to doing this at first. They're saying, why should we even have a build process for reuse code? You know, I want the zip, or I want the you know, just SVN checkout, and I get the reuse, and there it is. But I would make the argument that just like source code control, the benefits of this upfront work will pay off down the line. It's going to prevent you from having major problems further in the future if you have things like a checklist, a VI Analyzer check, and a build process. If there's any questions, by the way, you know, put up your hand. I want this to be interactive. The more you talk, the less I talk, and my voice is not holding out the greatest. So feel free to interrupt me. All right. Here I'm going to have an example of how to structure your reuse code. And again, packager agnostic at this point. We're not even talking about how you're building, how you're distributing. That's not part of this yet. I'm just saying, let's say you have some source that hopefully is in source code control to something that you think is good and polished and should be built and should be distributed so that others can reuse it. So I have some source on disk, and I'm going to turn that into a package. Now, again, here I showed the VIPM package icon. It can be anything, doesn't really matter. So I make a package. I distribute that package And when I install it, it's going to go to the installed location. So there's going to be essentially 2 copies of this on my disk. The source, which is in source code control, and then the installed location. Now those files could actually be renamed in the build process, they could be modified, but that part doesn't matter. What matters is that we go from source to a build to an installation, and now we have this in 2 places. So now I'm going to make a new package that relies on package A. So maybe one is I have a string package and I have an array package, and maybe my array package uses some of the string package functions. So I have package B, source, on disk, and your initial reaction is going to be to call the functions that are at the package A source, because that's what's on disk. That's what you have in your source code control. But if you go down this path, you're going to have problems. You're going to make that package B, and then you're going to install package B. But now package B is going to link to package A's source, which is fine for you. You have the source and the build on your machine. But when you distribute this to someone else, you're not distributing the source. You're distributing the built information. You're distributing package A and package B. They get installed, and they're going to have a dreaded searching for VIs problem when they install package B, because it's going to be looking for it in the wrong location. So what you need to do is this. Build package A, just like I said. Package B needs to be dependent on package B's or package A's install location. So this is most likely going to be like the user library if we're talking JKIs, BIPM. Build package B gets installed, package B and package A can be distributed, and they're totally just fine. And this might mean at times having to think about what functions should go in what packages. You have to have a kind of a conscious decision, and maybe auditing your entire reuse library to think, does this make sense to go in the array package or the string package, or should this be its own toolkit? Who's going to rely on what? You really need to do an audit of that, of figuring out what makes sense on who's going to depend on what. And one good reason for that is you want to avoid circular dependencies. You don't want like the array package to rely on the file, which then file depends on the array, and building one will mean that the source change that you need to build yourself, which means you need to change the first one. It goes on and on forever and causes problems. This may seem obvious, you know, when you have 2 packages, you don't want them to rely on each other, but when it's not quite as obvious is when you have a long chain of packages and you don't realize that they link to each other. So one example I have is this is one of our older reuse libraries at the company that I'm at right now, where each of the little blocks is its own package, and the arrows is the dependencies. So I call this the dependency line. So for example, we have the variant repository is a pretty low-level thing. It's like the foundation that a lot of things are built on. And so it's needed in the array package. The array can do various variant functions, and so it relies on that. And you notice that everything more or less just flows straight up. I don't have, at the very top, I don't have this then coming back down and saying, oh, well, the variant repository actually depends on the glued framework at the top. That really wouldn't make sense. Yes, Chris?
You know tool that can generate this?
I started to. There is a, on Lava, there's a tool someone posted that is like a command line flow diagram generator. And I started to try and do this, but the thing that I found is that a lot of these relationships they get so large and nested that it doesn't look good. Like I can auto-generate it, but it's a jumbled mess. And so this I kind of made myself. Yes? That's the one I was thinking. Yep. So node map is what you can search for in Lava. YED. YED is the tool that is, and it's a command line that generates an image that is all of these things. It's Excel as well.
There's another tool, it's John McBee that presented at this summit. I'm pretty sure it's online.
Okay, John McBee also has a tool. Okay. So all I'm getting at is to make it look this good though, I basically say you need to move things around and manipulate them. But you can programmatically figure out what the dependencies are, which is the first step. And so I have this actually printed out at my desk, and every time I'm making a change to a library, I'll kind of reference it and be like, oh, am I adding a new dependency? Do I really need to add that? You know, can I put that somewhere else? and kind of do that self-evaluation of where it makes sense to put things. And so this is just one of those things that I have on my desk to kind of reference. And so I'll often be like marking it up too with, oh, I added this new dependency, or this is moving up a revision, or whatever. And then the other thing that I do, but you don't necessarily have to, is each package has its own version, as you can see here. But then we have a major version of 1.4, which is the culmination of all of it. And that's kind of like a milestone. That's kind of like saying, if you have 1.4, here's what you all have. Now you can have updates of various packages on their own, but for me it was great to have that and say, okay, every developer is on this version at least. I can rely on them having that. And then beyond that, it's up to the developers to upgrade. So now that we got some of that general high-level stuff out of the way, let's talk about VIPM. There was a lot of people saying they were familiar with it. It's been around for, like I said, a while, at least since 2008. And so it's a package manager made by JKI, which is actually installed with LabVIEW in most cases. I think it's by default. I can't remember if you have to check it or not, but it's at least distributed with all of NI's copies of LabVIEW starting in 2012. So I can't remember the exact version, but it's software made to package up LabVIEW VIs. The free version allows you to package things up and install them and add dependencies and see how things go. And this isn't meant to be a full tutorial on how to use every feature of it. It's just kind of saying this is out there. There's a lot of good tutorials. But some of the cool features is definitely palette editing and pre and post VI calls. Those are my favorite things about it. When I first saw VIPM, like when I was doing my senior thesis, that's what really drew me to it. Was you point it to a folder of source and it makes a palette for you. The palette's usually not exactly what you want. You can move things around though in a drag and drop idea, and you can right click, add subpalettes, or add VIs, or add controls. You can inline them as well, so you don't drop the VI, you drop the contents of the VI, which is also useful at times when you're dropping like a template. So all kinds of cool stuff. And then there's the pre and post VI stuff, which I'll talk a whole lot more about, but it's allowing you to run code before an install, or after an install, or before an uninstall, or after an uninstall, or even during a build. So you want to prepare your code before being built, or you want to revert your code after being built. There's all kinds of that kind of functionality, and that really allows you to augment anything that you want. So this is no longer just put files on disk. This is put files on disk and do work that finalizes that install. Package dependency is really easy to use. You type in which package you have a dependency on, but if you have the pro version, it has a scan option. You just say, tell me what packages I depend on. And it looks at the source and looks at which functions that source is using, and then it includes them, which is like amazing. Wish NIPM did that. Okay. And then the pro version does add a couple of other neat features like publishing and subscribing to repositories. I've never used these personally, but they are useful so that when you launch VIPM, it can tell you if there's been updates to packages that you have already installed by looking at a feed. And a feed can be hosted on something like Dropbox, or it can be just a local network drive. So if it's within your company, you can have it be // IP address / VIPM repository, and that's all you really need. So you just push stuff to there, and anytime someone launches VIPM, they'll be prompted to update. So you could have a build server that does a build, publishes, and then maybe sends out an email so that the users are notified of this update. Oh, and the format is a glorified zip, which is great because you can just extract it if you have problems installing. If you don't have the right version, or if you have conflicts or whatever, they're probably there for a reason. You're probably trying to put it into a version that you can't for a reason, but you can always just open it and see what's inside. It's not locked down. All right, so I mentioned that you can do more than just place files. You can do pre and post stuff. But what I really want to say is it's also more than just toolkits, right? Obviously, we can add stuff to the palette. That's the main draw to it. You install OpenG, what do you get? You get a palette of cool OpenG stuff that you can use. But you can do a bunch of other things. You can add quick drop functions so that you install this package and now you have a quick drop that can check out SVN or commit SVNs or align your front panels or auto wire or all kinds of really cool stuff. You can also modify quick drop shortcuts, and I have examples of that too, where I prefer a lot of the quick drop functions to be one letter if it's a constant. So like cluster constant is just C, and array constant is just A. So I do quick drop C, quick drop A. And so I have a quick drop package that adds a bunch of the shortcuts to it. But you could remove them or update them. You can add things to the tools menu, the help menu, the file menu, which is also a lot of neat tools can come out of there. Project provider, which is basically Project Explorer extensions. So when you see your project, you can right-click a file and do things to it. I know that's pretty nebulous, but that's because the toolkit is that open in its functionality, but it's kind of hard to use. It's not well documented. But like the application builder is all built off of that stuff that you right-click. Is that a question?
Yeah. So there's an installer from measurement computing, for example, that is not VI package manager. Can you have VI package manager say install that and other packages along with it?
I want to make sure I understand the question. Are you asking, can VIPM install NIPM packages?
Can VIPM install a setup exe that could have been made as a VI package?
So can VIPM install an exe that was a package, Chris?
Yeah, so we actually do that specifically for like vendor drivers who don't export their APIs as VI packages, but as an exe installer. Part of pre-install, which we'll get to here shortly, part of pre-install is to execute that installer and then install the VIs that wrap that installer. So you're just programmatically interacting with the vendor's executable.
Right. Yeah, so for the video that didn't pick it up, Chris has a solution, packaging it up, and then a post-install VI is called, which executes the exe. Yeah, so it's possible. Because that's the other thing is, I've been talking about VI packages and package manager, but you don't have to put VIs in them at all. I mean, we do, because that's what it's kind of built around. But VIPM has this concept of system packages, which is not for a version of LabVIEW, it's for your system. And your system can install anywhere, your My Documents, your C drive, your wherever. It's just more convenient for us to talk about packages installing for a version of LabVIEW, which is great because during the install you pick what versions you want to install for. So just quickly run down the rest of this. So yeah, I mentioned Project Provider. You can add right-click framework with a package. VI Analyzer tests, I like this one. So we have a package that is our VI Analyzer tests that we install that now is the VI Analyzer tests used to validate reuse functions that will be in packages. So it's kind of this circular thing. We're using packages to distribute the test code for packages. Project templates, VI templates, and then customizing your LabVIEW INI. I like that one too, where I'm not more. I'm not going to do another show of hands, but I don't know many that like the drop a terminal as an icon on the Y. So why not make the INI key that on install just gets rid of that, or gets rid of the splash screen. I don't need to see that, or various other things that we can all agree probably don't need to be there. There are some user preferences I don't want to touch. I understand. Some like their auto tools, some don't. Some like having scripting turned on, some don't. But there's some of these that we can edit the INI, but leave the file intact. So whatever preferences the user has put in there already is left. We're not replacing the entire file. Okay. So we've already talked about pre and post a little bit. Here is some of the main things that I use it for, at least, and then we'll have a demo immediately after this. So adding password, and some of these can be done with the Pro version. Some of these are not. Some of these are locked down, some of these are locked down to only the Pro. But because you can do pre and post install and uninstall in the free, you can kind of do some of these as well if you're just testing it out. So like I can have a post install VI that then adds all my passwords. Or I could have a pre-build VI that puts passwords on them, it gets built, and now it's already got passwords on it. What I like to do actually a lot of times is just lock the VIs. So if a developer is like drilling down into their code, they might not realize that a function is in the user library, and they might be like probing around and trying to fix things, and they might actually edit it, not realizing that that code is a little bit sacred. It's not supposed to be tampered with once it's installed. So I'll lock the VI just as kind of a soft, it should stop kind of thing. They can unlock it, Control M, yes, unlock, that's fine. But it's kind of a first barrier to make them realize this is not a VI that you should be editing. But you could also set the files as read-only. I had some issues with that one, but you could have all your installed packages be read-only files, so now saving is not possible without changing the file attributes. Disabling automatic error handling and turning off debugging. These can be controversial at times, but remember, these are reusable toolkits that I'm talking about. These are code modules that have been tested and figured out, and they're robust and they're well, and they're not doing something like a simple error handler inside. They're always passing the errors back up to be handled. So in my opinion, all of these things that are toolkits at least can just do that on all. Turn off debugging on all of them, except example VIs. You probably do want to be able to probe around in an example. But turn off automatic error handling, separate compile code, generate documentation, and update the VI description. So I update the VI description to say what package the VI came from, what version it is, what version of LabVIEW it can be in. You can add all kinds of information in there so that when you hover over the VI, you can know where it came from. And then pre and post.
I have a question about that, like updating your descriptions and things like that. That is done, is that not something you'd want to do to put in your package, like your VI is already with the information in? And basically, you're just taking the VI without the description, I can extract it from the zip file.
So yeah, I'm saying this is part of the pre-build.
Oh, I'm sorry.
Yeah, no, that's fine. I got pre and post as another column for install.
It's the pre-build. not the
Pre-build,
install.
yep.
Okay, never mind.
Eric? Yep.
So I'm assuming you've already checked these changes into source control before you're doing this.
Yes.
So.
Oh, well, sort of.
Sorry.
I'll let you finish your question, but it might change my answer.
I'm wondering if you've ever tried to generate a change log, put it to the VI description from your source control when you're doing this. Like this version has these bugs fixed in it, but if I just pull the comments right out of source control.
So I haven't done that in an automated way yet, but I do that manually. So when I'm committing code to SVN or whatever source code you should be putting in comments saying this is what I changed, this is what I fixed, whatever. And then when I go to build a package, I'm usually just copying those comments and pasting them into the build specifications in VIPM so that you can look at it and say, oh, this is what actually changed. And then that links back. Okay. And then some of the pre and post install and uninstall stuff. You can set custom palette widths. I mean, you can edit the palette yourself at edit time, which is kind of fun. So on install, do whatever you want. You can add it to the native palette. So I can add array functions to the native array menu. That's a little risky messing with, again, files that are somewhat sacred. But you can place things wherever. Setting library menus, which is great for if you right-click a class, you get a palette that is specified for that class so that your common functions that are used there come right up. I mentioned adding and editing the contents to the LabVIEW.ini, which is super cool. Adding and removing quick drop shortcuts and preserving them. I don't want to step on other developers' toes, but I want to add new things. And then modifying code based on what is installed. And I can give a couple of examples with this quick drop insert. But the first example is just going to be a very basic one. So the second one is more quick drop related. So, I have a couple of packages, but I'm really just going to look at this first one, which is application control. And so, in VIPM, what's the launch? So here's VIPM for those of you that don't know. I'm not connected to the internet, so don't update. Alright, so here's the basics of it, and I mentioned release notes. This is where I would just copy in, the SVN commit information that I copied, and then up revision everything else. Adding icons, basic descriptions. Here's the palette of various cool things that I'm adding. But the main thing that I want to show off, because I think all of that is relatively basic, but some of the other things I want to show off was this pre-build and then post-install VIs that get called. And again, all this code is going to be available after the presentation. It'll be online, so you don't need to worry about it. But here is this pre-build that when I run it manually, it allows me to pick a package to apply the pre-build to. So if you don't have the Pro, you can just run it yourself, right? I mean, it's saying, run a VI before I build. Well, I could do that if I have the free version. And so what does it do? Well, we have a state machine that doesn't fit quite as well on this resolution as I'd like. But you can go through and see all the various things that I do. But it's a lot of the stuff that I've already talked about where, we're just figuring out what the package names are, if it's not passed to us, opening each VI, well, this is finding each VI. Here's where we're editing the VI description. So we're adding the product, we're adding the product name, the package version, the minimal LabVIEW version, various basic things like that. We're updating, we're disabling automatic error handling or compile code, we're locking the VIs, we're setting custom titles, and then we're just processing every VI. So the rest of this is more or less error handling of that kind of thing. Oh, and then here we're separating compile code. It's all those various things that I said, basically any toolkit that is used as a reusable toolkit should be done. And so this is all on that pre-build that I talked about. And then post-install, it's relatively basic. Oh, this is actually not even needed. I'll have to update this before I post it. But here we're setting the palette width to 4. VIPM, for some reason, always defaults to 3 wide. Like here's the open G, and you can see we have 3 columns. And once you get a significant number of packages, I kind of prefer having 4. And so this was a relatively easy thing. To just say, here's the NIWeek that we created, update the width, write it, and that's it. I have this disabled refreshing the palette, which I don't think you actually need, but that's it. And then this is some extra stuff for handling the menus that I talked about earlier, so that when you right click on a class, it brings up a specific palette. So like, if I can come up with an example. So here's a class that when I right click, it brings up this generic driver palette, and I was able to define what that is. And so this is handling some of that. And it's just finding the most high-level palette that this package uses and then linking it to that. So all these pre and post things will be available afterwards. And that demo is not nearly as cool in my opinion as this one, which is the quick drop demo. And I've already alluded to it a little bit, where I'm adding quick drop shortcuts and I'm adding quick drop functions, as well as augmenting the quick drop functions that are already there. So for a quick demonstration, well, I'm not going to do another show of hands. I already did. Gotta stop that. So I use quick drop a lot, and the quick drop functions are like super handy to make fast coding. So I'm opening a file, I'm writing a file, I'm closing a file. I'm going to wire them together. Pretty cool. So now if I wanted to insert something in here, I could say, oh, I need to insert, I have this open, I got this right, I need to do a read. Okay, I could do quick drop, read binary file, Control-Shift-I will insert it on both wires, which is what I wanted. And that's fine, that's great. But what if I had that object already in my clipboard? Like I have this this write, I want another write right here. So I'm going to select it, copy, select the 2 wires, quick drop, and then just say Control-Shift-Insert. And it inserts whatever was in my clipboard. And I can do this on multiple objects too. It doesn't always work as well, but I'm going to try it out for demonstration purposes. So Control-Shift-I, fingers crossed, there we go. And it inserted, it didn't quite work as well. Inserted these 2 functions and then wired that up. And I did this a couple of ways. I'm supporting quick drop insert with multiple objects. I'm also supporting it with from the clipboard, which is super handy to me. But I'm using the built-in quick drop inserts to do the actual lifting. And to do that, I actually had to edit the installed insert.vi. That it has some undo operations that I need to have it not do. Like I need to call into it. And now I could have done this a couple of other ways. I could have included my own copy of the insert that the native functions do, but I didn't want to overwrite whatever insert you might have, especially if NI down the road improves their insert functionality to work better. So on post install will edit the VI. I will add disable diagram structures, but I'll also make a backup of your original so that if something goes wrong, I can restore it. And on uninstall, I will restore it. So that you get your functionality back. And this also works on replace, by the way. So if I copy a function, quick drop P, it just replaces it with whatever was in my clipboard. And it works better with malleable VIs and polymorphic VIs. There's a couple of other edge cases. The wait function I also added. So if you do quick drop W and Control I, it inserts the OpenG wait. But if you just do W up here, it does a wait with a constant that you can set, whatever you want to. And it works the same with the tick count. If I insert on a wire TC for tick count, then it inserts the OpenG tick count. But if I just drop it, it drops in the native tick count. So for me, this is more convenient because I'm never inserting a wait on an error wire and wanting to be the NI wait because that doesn't have error in that. And then the other thing is the shortcuts themselves. So I have a bunch of them here, and there's a bunch that were already installed, but I added my own and didn't remove the ones that were there. Again, I'm going back to I really want to preserve the settings that the user might already have in their LabVIEW.ini, and this is one of those things. I didn't want to just replace the whole thing. So I think this is on post install. No, this is the wrong one. Here we go, pre-install. So these are functions that again I'm providing, but they're part of that application control package that we made earlier. So that means that the quick drop package is now dependent on that application control, and I need to be aware of that relationship, avoid circular dependencies, all those kinds of things. So here is the code for getting rid of some shortcuts like TC and FC. I prefer using those for tick count and first call because by default TC is supposed to be true constant. For me that's just T, false constant, which is just F. And then here is this VI that adds all these shortcuts already. And this is open, you can look at how it does it, and formatting and a couple of private methods. These are all things that NI uses when you open this quick drop configure dialog and change them. Those are all the same functions that they're calling into. So they are private, but the code I copied from what NI is doing. So hopefully it's safe and stable and we shouldn't have to worry about it. All right, any other questions on those two examples? No? Everyone likes it? Everyone thinks they're going to be using packages for distributing their LabVIEW.ini settings from now on? Okay. So let's have a quick slide on the free versus the pro. I've mentioned a few things. Free can basically do everything that you want for a single developer. You know, they're able to make packages, they're able to version them, add dependencies, all that kind of thing. But the pro does have a couple of compelling features. Certainly the publish and subscribe to a repository, but that you're going to want for every developer. So that could become costly. But if you simply want it for one pro license, one of the major benefits is the package of packages, which is their VIPC. So I can make a collection of packages, and just like you saw earlier, I had that version 1.4 release of my reuse library. That is a single file on my network drive that I can double click and install on a computer. I can put it on a thumb drive and go to a computer that's offline, just double click it and installs it. And it puts in all the OpenG packages, all the dependencies on that. Those are all included in there as well. So it's not just my packages, it's any package can be inside this package of packages. And double click just opens it up and installs it for a version of LabVIEW. So for me, that at least justifies that one pro license cost to have the pre and post build VIs and have the creation of VIPCs. Another thing that I've heard VIPCs used for is scanning your project to say what code that project uses. So it can be used as a configuration management tool a little bit, that you're in your project and your project's done now, you've delivered it, your customer likes it, and you can scan that project to say what packages does the project use, and then send those to the customer as part of the source. You don't have to give them your entire monolithic LabVIEW reuse library with a ton of stuff that they don't use. You just give them the packages that you actually used in your project. So I thought that that was a really neat tool, and it's got that automated scanning process.
Hey, Brian,
Yeah.
so it sounds like I have to ask VI Package Manager based on the project or the dependencies. Can I ask VI Package Manager based on a VI package what its dependencies are?
Yep. Yep. In the window where you're setting up the dependencies, there's a scan button, and it just finds them all. Magic. $500 per user per year. It comes with a year of support, so you can continue. Yes?
So when it scans, does it also scan for hardware drivers?
No. What it's basically looking at is, it's saying for this folder of VIs, what VIs does it call that are already in packages? And then come back and tell me, here's the list of all the packages that this needed. Yes?
Can you also include sequence files for test stands or just the S?
Can you include sequence files for test stand? Is that what you just asked? I'm sure you can. I've never done that. You do? Okay. Okay.
And there's like larger site licenses too, so if you don't want to get like 10 people, it doesn't necessarily mean that's $5,000 now.
Okay. So there is site licenses. I wasn't aware because I haven't had that opportunity.
The ability to packages VIs that call into the DLL or something. Will it automatically pull the DLL in, or do you have to install it?
From what I've experienced, it automatically pulls in the DLL and will make a folder that I think is something like external dependencies or something, and then the VIs are linked to that DLL. So I say that because everything I've used it on is seamless. That I just tell it include these VIs, and when the package is built and it gets installed, those VIs are there with the DLL that it needs as well. I definitely recommend testing in a virtual machine though if you feel like it. Microsoft has a few virtual machine operating systems online you can download for free for testing out. It's supposed to be for testing out Internet Explorer operability on web pages, but for quick stuff like this, it's great to just say, install package manager, install LabVIEW, install these packages. Does it work the way it should on a fresh sandbox? And then you can make adjustments from there. I definitely like using that. Yep, I basically covered. So it's nice to have just a build machine at some point. So when I first heard about, what time did I go to? Sorry.
You got 15 minutes.
Got 15 minutes? Thank you. So when I first heard about NIPM, I thought, okay, VIPM's going away. And I didn't think I would ever give this presentation because I thought VIPM's just not going to be useful anymore. It's NIPM's coming in, they're taking their place, and this third-party tool is now being replaced with a first-party tool, and that's how it is. Unfortunately, that's not the case today, and that's not the message that NI is trying to convey. So at the moment, these two package managers more or less support different things. NIPM is primarily for applications. You can break up your application into smaller chunks, and they can depend on each other. Now the benefit of that, though, is NI is distributing their drivers and their runtimes as NIPM packages. So you can have your application depend on an NIPM package that when they install your package, goes to the internet, downloads the runtime if it's needed, downloads the DAC if it's needed. And that means that your package is small. And even in 2019, they added the package installer option. So you make a package, then you make a package installer. Now the installer is small because it doesn't include the runtimes and all those things. But on install, finds them from various NI feeds for all their stuff. So primarily that's what NI's message is. It's not to replace JKI's VIPM at the moment because we're missing things like palette editing. That's the first major. That's the first thing of, I want a palette that I can edit so that when I install, my users can find, my developers can find my code easily. They're going to be browsing the palettes looking for functions. I want my stuff to show up. Pre and post VIs are also not there. They have pre and post EXEs or batch files, which can do similar stuff, but is more of a pain. But the biggest thing for me is NIPM is more of a generic package manager, where VIPM is kind of like LabVIEW centric. NIPM, if you install a package, you have to define the path where it goes, and that path can't be a version of LabVIEW. It can't be like NXG 3.0, and then when 4.0 comes out, you install the same package. That won't install for 4.0. That's made for 3.0. And so VIPM, you make a package, and in the configuration you say, this is for LabVIEW, whatever, or newer, and you just install it, and there it is. It just works. So you have pre and post EXEs, palette editing, packaging source. You probably could make it work like VIPM, but I think that would be a whole lot of extra work trying to wrap things up to make it work that way. But what you'll usually end up with is, like I said, you'll have one package for each version, which is not good, especially for toolkit developers. Oh, and then there is a link at the bottom that, again, these slides are going to be available. You don't need to take a picture. But where NI is talking more about how they're suggesting using NIPM. And then what's the pros and cons? I don't need to spend a lot of time on this. I already went through a bunch of them. But one thing I will mention is this Runtime API, which is super cool. VIPM does have an API, but it's for pro users only. And it's for things like automating builds and automating pushing to the repository. And NIPM is free, and so it includes a bunch of stuff like this. There's a command line interface. There's also an API for doing things like checking for feeds. And so one example that I haven't explored yet is you can have your application register for a feed on startup and look to see if there's a newer version of itself on that repository. And if so, prompt the user to update, which will spin off a new EXE that does the update, install the new NIPM package, and then relaunch your application. And so this is the discussion where the beginnings of that are in place. So I suggest everyone checking that out. All right, and then the new challenger approaches, GPM. This is the new kid on the block that there's been a lot of discussion about, and I personally haven't used it, but I can describe some of the benefits of it and why it was made. Made by MGI, awesome guys, by the way. They made it because they wanted it to be a project-focused package manager. One of the benefits and drawbacks of VIPM is that it's on a version of LabVIEW. If I install a package, it's on that version of LabVIEW, and every project I use in that version of LabVIEW will look for that code in that version, which is fine if you're okay with having the same version of a package being used on all projects. Some of you are on military or aerospace or biomedical projects where revalidating is a major pain, and so you're going to have projects that maybe use one version, but you don't want to update. You have other projects that are using another. Now, I know one of the solutions is virtual machines. You know, sandbox, put everything in there. And that, if that works for you, that's great. But I'm getting the message from MGI that they like this strategy better, where you're installing a package for a specific project, and that can be version specific for each project. Yeah. There's a bunch of good stuff on it. Command line support. It's installed through NIPM, so a quick command line install. And I guess some of these other things might have changed since then. I said that there's no private or offline repository yet. I guess I shouldn't put that one in there because things have changed since I made this presentation. Yes, Chris?
The only thing I'd add is it's open source.
It is open source. There you go. JKI's VIPM, they made a name partially out of that, and so it's closed source where this is, you can open it up and make all the changes and cool stuff you want.
Please do.
Thank you, MGI. Okay, and so I think my time's pretty much up. Oh, I got 2 minutes. And so this is more or less a summary, FAQs that I probably already said. NIPM is primarily an alternative for application building. You should look into using it for that because I think it's got some cool benefits. But source code distribution is where it's lacking. You probably should avoid it for that. That being said, OpenG was rebuilt for NXG using NIPM, which I thought was a pretty cool challenge that Jim was able to actually succeed in, but he described some of the hardships for sure in doing that. VIPM is my preferred way of doing LabVIEW reuse. I should have said instead of the preferred way. Free version or pro version for $500 or corporate licensing, which can help out. GPM is free and open source, I should have said. And pre and post calls do all kinds of cool stuff because I love scripting so much. Okay, my last slide. What's up?
I have a question. Okay, so can you use NIPM? You mentioned like distributing like applications that are built in different parts. Can you use it to distribute PPLs?
Yeah.
Okay, cool. That's what you're referring to.
Yeah. In LabVIEW, I think 2017 or 18, I can't remember which version, but they added it under the build specification. So in your project, you can say new build and new exe, new installer, and new package, and then you can select the source. I think source can only be an exe, or there's some limitation. You can't do like just AVI.
Right. Okay. Yeah. I knew you could do one VI. I didn't know if it.
Yeah. It can do other things. It can't do just AVI. Put it in the NIPM. That being said, I saw a tool someone made for NIPM which calls into their command line utility that lets you package up anything, and I'm guessing that will let you get around that limitation.
NIPM can push updates to these machines. You user go with that machine, log in and make the update.
So the question is, can NIPM automatically push updates to remote machines? That's where, and I would likely suggest SystemLink, which is their distributed system management software. It does a whole lot of cool things, but the major bullet point for me, at least, is you can see what NIPM packages are installed on remote machines, and you can install them remotely. So you can have a central server that is monitoring all these, and you can push out updates. I don't know how well that works yet. I'm absolutely interested in it, especially for application development. I have an RT machine that's running some code. It's idle, not running a test. I want to try and push the newest update, and I want to do that on a whole fleet of them at once. That's the message is. I just don't have experience with that yet. Okay. Any other questions? All right. All the source and slides will be available online. Come talk to me if you're interested in more afterwards. Thank you.